Welcome to Midlife, mitochondrial dysfunction and metabolic health. It's a passion it's a topic I'm very passionate about. I talk about it probably a lot more in kind of other contexts, but I really wanted to, as it's Menopause Awareness Month as well as Breast Cancer Awareness Month, I wanted to offer something that wasn't breast cancer related, but that's applicable to most people, most women anyway. And I wanted to share a little bit more about what happens. But actually, a lot of what we're going to be talking about today isn't just menopause related, it's actually related to aging. And I think it's a super interesting topic. So I am going to share my screen and I'm going to also minimize everyone in a second. Here we go. I'm just going to minimize everyone just so they can see me. Oh, or not. That's weird. Okay, that's show it just means it shows you. So I don't wonder why it doesn't show me. Okay, well that's interesting.
I can see you, Toral.
That's okay. Now it should minimize. No, minimize. Now it should move. Okay, now it shows me. Perfect. There we go. So for those of you who don't know me, so there's definitely some new faces. I'm a nutritional scientist and researcher. I originally went to medical school to become an oncologist, realized that that was not the right job for me. But I also realized that we weren't doing enough about nutrition and lifestyle. We weren't learning anything in medical school. And this is obviously going back quite a long few years ago, like actually it was 30 years ago I started medical school. It shows my age. And I basically moved to do a master's in nutritional medicine, specializing in cancer, particularly breast cancer and prostate cancer. I wrote my master's thesis on kind of the diet and lifestyle that helps to reduce the risk of cancer reoccurrence and nutrition. And I've had breast cancer myself 3 times. But I am trained in functional integrative medicine as well as the nutritional medicine and genomics. And I'm a very passionate speaker and writer and advocate. And I do lots of academic research too. So this is just really, it's not come out very well here, but really the title for today is the Midlife Metabolic Health and Mitochondrial Function. And I might have to move my face so that you can see everything on the slides, but we'll see how it goes. So, first of all, what are mitochondria? Mitochondria are the powerhouses of our cells, and they're literally our energy packs, our kind of battery packs. And what they do is they transform our food into ATP. ATP is what we utilize in our body, and what our cells, more importantly, use as their energy source. So mitochondria are super interesting. I don't know if you remember them from GCSE biology, but they're included in all our cells. But they all have their own genetic material, which is so interesting because you can only inherit this from your mother. You cannot inherit this from your father. They have this double kind of membrane enclosure, meaning they have this folded internal part and its smooth external part. And that folded inner membrane is where a lot of the reactions happen. And they're present pretty much in every cell in your human body, particularly on those that need a lot of energy. They have a lot of not different, they have a lot of mitochondria. And what's interesting is that and I can't remember the name of the book actually, but there was some really interesting research showing that they may have kind of developed, as obviously when the world developed, we had single cell organisms, and this may have been when kind of sort of life developed, that there were some free living bacteria which kind of ate up some of these other bacteria and cells, and they formed mitochondria. So that's the science kind of bit of what mitochondria are. But really, what you want to think about them is our cells' own power plants. And we'll come back to that quite a lot today. So what is the role of mitochondria? We've got them in lots of different cells. There are lots of different things that they do other than produce energy. So they do produce energy using oxygen. They use the carbohydrates and fats from our diets to make their currency, which is ATP. However, ATP is really important for all our body activities, whether it's our heart beating, our muscles moving, any kind of chemical reaction, but anything that to do with our cells being healthy is really important. But what a lot of people don't really think about is that calcium regulation is also occurs with the mitochondria, because the mitochondria store calcium cells, and this is really important for our neurons and the transmission, the spread of our neurotransmitters, which are the amazing, like almost chemical messengers that take around our neurons, and also muscle function. There are also make heat through this thing called proton leak, which maintains our body temperature. We know our body temperature is normally 37.2 or 3, whatever, but it's particularly important in brown fat. We can have white fat and brown fat, and heat production is really important. So when you're cold and you're shivering, this is called thermogenesis. This is when our cells are making a lot more heat by that movement. They're also really important for making carbohydrates, proteins, and fats. So they're kind of a metabolic center. They also do cell signaling. So they tell cells when to cause inflammation for the immune response to it, and also if they actually program cell death. So the way our cells work is they've kind of got a bit of a life cycle, and our cells in our body, they talk to other cells in our body and tell them when to kill themselves, when they're either damaged or they're not needed anymore, and that's what they do. But they're and mitochondria are really important for fertility and our embryos. Now, it's something that we probably don't think about, but because obviously that's ending at this point, but it is something that's, if you don't have very good mitochondrial health, then you might find it very hard to get pregnant, and to also maintain pregnancy and maintain that embryo. So I like this slide because it's just got a really clear description of all the things that our mitochondria do for us. It's something that we don't necessarily think about, but they're a very, very important part of our health. And now we're starting to talk about in one that's kind of a buzzword, mitochondrial dysfunction. So mitochondrial dysfunction, if when they these mitochondria aren't working very well, we don't have as much of the energy we make. So we don't have as much of this ATP, and that's really impacts a lot of this tissues in our body which need a lot of energy. Like muscle needs a lot of energy because if you're moving a lot, then they won't work so well. Same with your liver and also your adipose, your fat tissue. When we make energy, we have something called reactive oxygen species. That's the ROS on here. ROS production is always made when we're making energy, but sometimes different types of energy making within our mitochondria can create more or fewer reactive oxygen species. But when the mitochondria are not working very well, you have this more increased oxidative stress, which means there are more of these reactive oxygen species, which can cause inflammation, but also it can damage our DNA, it can damage other cells because they're basically, if you remember from your GCSE chemistry, they're reactive because they've got a loose electron. So that's really important. And what actually causes mitochondrial dysfunction? Obviously, aging. Aging is really, really important, but there's also different lifestyle things that can make a difference. So if you're very sedentary, that can affect mitochondria. If you get infection, so there's something to say that even with COVID, like a lot of us are getting infected, and that could have infected your mitochondria. Also, if you've got genetic mutations, that can damage your DNA of the mitochondria, and also kind of keep creating DNA damage. And then this causes is linked to aging. The more you age, the more likely you are to have these DNA mutations in both the mitochondria and also the nucleus of the cell. And this creates more reactive oxygen species. So, what is metabolic health? Metabolic health is how our body works, our metabolism. So, there's lots of different aspects of metabolic health, and we can measure these. And these are regularly measured when you might go to see the GP, particular at this point in life, midlife. So, your blood sugar, your blood glucose levels, your triglycerides, which are your fat levels, your high density lipoprotein, that's your cholesterol, your HDL cholesterol, your blood pressure, and your waist circumference, and that's without taking medication. If you have certain of three of these which are too high, then that can be linked to something called metabolic syndrome. And the impact of that is obviously you have more risk of cardiovascular disease, you have a higher risk of providing type 2 diabetes, but also greater risk of stroke. So we'll talk a little bit more in detail, but metabolic health is actually a little bit of metabolic flexibility where your body can use the food that you eat to produce energy efficiently and cleanly. And that's one way of thinking about it. So, what's metabolic syndrome? And I like this one from the metabolic syndrome from Canada because it just shows what you're looking at. So, if you have a waistline of 35 inches for women, over 35 inches for women and over 40 inches for men. If you have a fasting glucose over 100 milligrams per deciliter, if you have HDL cholesterol, which is at less than 40 milligrams per deciliter, if your triglycerides over 150 milligrams per deciliter, and your blood pressure is high, so it's over 130, over 85 or higher. And if you have three of those, you can have metabolic syndrome. And it's just a clear indication that your metabolic health is maybe not as good as it should be. There is lots to do, but it does increase your risk for these diseases, as you talked about. Just going to touch on South Asians a little bit. So South Asians have poorer cardiometabolic health in the first place. There's so many reasons for that, but I'm just going to give a really quick précis. But essentially, we've had epigenetic changes. This is due to British colonization during the 19th century, so the 18 somethings. And in that particular time, we had 24 famines in what is now kind of India, Pakistan, Bangladesh. Um, and those 24 famines within a 50-year period changed people's genetics and how they react to their environment. So they became much better starvation adapted, meaning when there was food, they were much better at storing fat in case there was famine. And this obviously changed and also they had less muscle mass to start off with. So South Asians, a lot of us have less muscle mass to start off with, and that impacts our metabolism and our metabolic health. And so if you're starting off with less muscle mass in the first place, the reason you had less muscle mass was because that had needed much less energy to maintain it. So South Asians do have slightly different cardiometabolic health. And it's important to think about this, A, if you're from a South Asian background, or B, if you're medical, because 25% of the global population is South Asian. And that means that you increase your risk of cardiovascular disease. We also have smaller coronary arteries, way more likely to have heart attacks. So just something I wanted to kind of highlight. It does increase obviously a risk of diabetes too, and there are all of these other factors, so cultural and social factors, impact on the pancreas, the diet, our kind of fat levels. We have higher LDL cholesterol levels. We have more sedentary lifestyle, less exercise, smoking. So all of these affect the body composition. So I just wanted to make sure I touched on this. So what about inflammation? So a lot of us hear about inflammation quite a lot. So why is metabolic health and why are mitochondrial dysfunction really important when it comes to inflammation? So when you have poor glycemic control and metabolic syndrome, so when you have three of these or more, you have metabolic syndrome. You will have obviously a dysregulated metabolism, you will have ongoing inflammation, and you'll be in more of a pro-inflammatory state, which means that you're more likely to get inflamed and you'll have dysfunctional mitochondria. So if you have metabolic inflammation, that leads to obesity, type 2 diabetes, insulin resistance, metabolic syndrome, so on and so forth. What leads to dysfunctional mitochondria are genetics. Also, if you're not very exercising, and what you're eating. And what can you do? And we'll go into more detail about how you can create healthy mitochondria, particularly in midlife, when your mitochondria are naturally aging. Oops. So it does say underneath there, mitochondrial dysfunction impairs metabolic health with age. So when a mitochondria become dysfunctional, these are cellular powerhouses. As we shared, those powerhouses convert our nutrients into ATP. There's a spelling anyway, and that normally regulates our metabolism, cell signaling, and stress responses. But when we age, the mitochondria become less efficient. And they also become slightly less clean, actually, is the right word probably to use. But what happens then is we make less energy in the form of ATP, and that really impacts our energy dependent tissues like liver and muscle, and that also impacts our glucose and fat metabolism. As we've talked about previously, it increases your reactive oxygen species, which can damage your DNA and your other parts of your cell. You also have a bit more mitochondrial damage and accumulation. Normally, our mitochondria know when to signal within themselves to kill the mitochondria when they're kind of dead, or they're not working so well, or they're dysfunctional. But when you get older, this mitophagy, this kind of cellular cleanup mechanism, it doesn't work so well, which means that all the damaged mitochondria kind of start to accumulate and they're not broken down and they're just swirling around. So that's not good for us. And also, then we have more likely to have mitochondrial DNA mutations, which is going to impact our cell signaling. And the last thing is oxidative phosphorylation impairment. This means that one of the ways in which we make energy from our food into ATP is something called oxidative phosphorylation, which needs oxygen, and that's how most sort of ATP is made. But this actually decreases as we get older, which means we have less energy. All of these things can impact your brain, which leads to cognitive decline and neurodegeneration, our muscles with sarcopenia, and we also have decreased endurance, so we become less fit. Our cardiovascular health, our heart doesn't work so well. We can more likely to have high blood pressure, and again, metabolic health, having insulin resistance and type 2 diabetes. And we're going to talk more about how we support that mitochondrial health in a shortly. I just wanted to touch on cancer because this is my area of specialty, and this is something that I've been trying to educate quite a lot of doctors on recently and thinking about when we do our research. So we know that, as I said, the mitochondria produce ATP through this oxidative phosphorylation, but they're really important for our programmed cell death pathway, so that they're almost the gatekeepers for this. So when the mitochondria are disrupted, we obviously have this DNA mutations. We also have enzyme defects, and we're more likely to have our tumor suppression genes and our oncogenes are more likely to be switched off, which leads to cancer progression and invasiveness of the tumor, meaning that when all of these mitochondria are disrupted, that you're more likely for cancer cells to grow out of control and to spread. And cancer cells, they don't use oxidative phosphorylation. They often prefer glycolysis because it helps them, even though it makes less energy, it means they can grow a lot more quickly, rather than being energy efficient, and spread more quickly and grow more quickly. So that's something that's quite interesting when it comes to how cancer cells behave, that because of the genetic change and the metabolic changes, they can grow a lot more quickly. So what about menopause and mitochondrial dysfunction? So you'll see from this diagram here, you can see estrogen. You can see that estrogen increases, and obviously premenopause, it's kind of stays relatively level. And that perimenopause, at this critical period, it starts to drop quite quickly. And then we get to menopause, and then it's postmenopause. And so in premenopause, our mitochondria are quite happy. They can make they've got capacity to make a lot of energy. They're balanced. And that's obviously linked to having a high level of estrogen. Now, when we get to that perimenopause, this is when it becomes, everything starts to change. Our glucose metabolism goes down, our ATP production goes down, our estrogen level goes down, our fat usage goes up, and the mitochondria start to create these alternative energy pathways. So mitochondria become less efficient. If we think about estrogen almost like a shield, I feel like that's very useful. So if you think estrogen is almost like a protective shield for our mitochondria. So when our estrogen level starts to drop, there's less of that protection and shield. So that's when they're more likely to get damaged. As I shared before, obviously there's less ATP production and there's more increased oxidative damage, meaning there's more of this reactive oxidative species. And again, there's less of this mitophagy, what is the cleanup within the cell to break down the dysfunctional mitochondria. And we know this leads to neurodegenerative and metabolic disease. Now, this may explain actually why women are more likely to get Alzheimer's disease, and other kind of neurodegenerative conditions, because we don't have that estrogen shield. Whereas for men, as much as their hormone levels drop, whether it's testosterone, estrogen, because obviously men have estrogen and progesterone too, not as much in the same way. So something to think about. The other thing that often happens is we are often in midlife more stressed, so we have more increased cortisol. Cortisol is not bad, it's a hormone, and we need it in the morning to get us up out of bed and to give us a get up and go and to be motivational. But it does need to drop at certain times of the day, like later in the morning and afternoon. Sometimes we just have increased levels because we're quite stressed, and then we're more prone to be in contact with environmental toxins. I think our world has changed so much in the last 50 years. So we've got a lot more plastics, we've got a lot more environmental chemicals, all of those things. And all of those things have been found to damage our mitochondria and their function, reduce their energy production, and actually to reduce the cell resistance, to actually damage the cell. When it comes to menopause and metabolic health, again, this also changes. And I quite like that this is the premenopausal and this is the postmenopausal. And you'll see estrogens high here, estrogens drop. FSH, which is a follicular stimulating hormone, that drops, whereas that increases when we're go towards perimenopause. The reason for that is that our body's frantically trying to make estrogen, progesterone, and we're not able to make it as much from our ovaries. And we can also make it from our adrenal glands. So that can impact us. But in menopause, with this loss of estrogen, we know that we have a change in our fat metabolism. We have an increase in our blood lipids, particularly cholesterol, partly because our body makes a lot of our hormones from cholesterol. So from cholesterol, we make progesterone. From progesterone, we make testosterone. And from testosterone, we make estrogen. So if we're not making those, then we're going to end up with more cholesterol. It disrupts our fat metabolism and our fat distribution, increases insulin resistance. This hormonal shifts in androgens, meaning that we testosterone changes and we have more of these androgens, and that can basically create central like more fat around our midsection, so central obesity, and that also impacts our cholesterol levels and our blood glucose. We also lose more muscle mass because people are exercising less. It's not like a prerequisite, but as you age, whether you're a female or male or any other gender that you can identify with, you do lose muscle mass unless you're doing progressive overload resistance strength training, and I'll share more about that in a second. um, and then the other thing is we have this higher risk for metabolic syndrome and cardiovascular disease. Then that's beyond what we expect from aging alone. And what people don't realize is that heart disease is still the number one killer for women. And because heart disease and heart attacks present very differently in women than they do for men, it doesn't have this sudden kind of heart pain and like the pain down the arm. It looks differently. And I should have included a little bit more about the symptoms, but I haven't. But it's a lot more to do with like having things like heartburn feeling, to feel tired. So just something to think about. So look up what the symptoms are for heart disease for women, because there's lots of them. And you'll see here that obviously increased with perimenopause and postmenopause, so with decreasing fat-free mass, you have a decrease in insulin clearance, your cardio health goes down, your bone density down, your sleep. And obviously, if you don't sleep very well, that increases your hunger the next day. It impacts your hunger satiety hormones, your leptin and ghrelin. So that's another reason that you can also put on weight. And there's so many different things that lead up to this. So what about the healthy versus the unhealthy mitochondria? So what can we do to support our mitochondria? So first of all, we want to be having an antioxidant. You'll see here there are all these very, very clear inner membrane. And it's making energy, making lots and lots and lots of ATP, the cellular energy. They're all the free radicals, the reactive oxygen species are being kind of neutralized. But as we get older, these damaged mitochondria stay within the cell. It requires that you can see the membrane is not quite so clean. It's lost its shape, making a lot less ATP, that cellular energy, and there's a lot more free radicals, and so the damage increases. So when you have cofactors, meaning coenzyme Q10, selenium, vitamins A, B, E, and K, these are all part of antioxidant spectrum, and they're very good at neutralizing these free radical and these reactive oxygen species. So we do want to think about making sure we're having antioxidant rich diet, supplementing if we don't get enough of certain things. If you do genomic testing, which I specialize in, then you can understand. So genomics are all of your genes. We all have them. Now, a lot of us have, we all have mutations. Some of these mutations which are very small, they're called single nucleotide polymorphisms. Some of those mutations can be more beneficial, some of them can be less beneficial, but they can impact things like your vitamin D absorption, your vitamin D transport, whether you need more B vitamins like folate. And so understanding that means we can actually eat in a way and or supplement if needed. And this is personalized to us. It's not just throwing things in unnecessarily into our systems. Um, the thyroid hormone, I'm not going to go into this in much detail today. This is a little pet interest of mine at the moment. So we're learning a lot more about our thyroid hormone. Um, but if we don't have sufficient thyroid hormone, a lot of women have uh, autoimmune disease such as Hashimoto's, Graves' disease, which impacts your thyroid hormone, or they're which is hypothyroid, meaning they have less of the thyroid hormone for lots of reasons. You can be genetically prone. Your genomic testing can show you whether you're converting tyrosine, which is an amino acid, a building block for protein, and iodine into our thyroid hormones, or whether you're poor at it. And also, there's other things that can damage it, like fluoride and chlorine and things like that. So if you're in touch, so these are things that really personalized care. But what we're understanding is that the thyroid hormone is very important for our mitochondria. If you don't have sufficient, it can mean that you don't have healthy mitochondria. Personally, I've realized that I've got hypothyroidism, subclinical, so not very, like, only a little bit less, and that's partly because I've had radiotherapy, and that's impacted my thyroid. So I've just started taking a very low dose of thyroxine, the thyroid hormone, literally 2 weeks ago. So I had nothing's happened yet. So let's see what happens, because obviously for me this is really, really important to have my mitochondria working well. Red light. Now, red light is the light that you see. It's part of our daily kind of daylight, but particularly at sunrise and sunset. And even if you live in a city where you don't necessarily see a pink sky, there is a little bit more of that red light. Now, one of the things that you may all have heard about is red light therapy, probably because you've all seen red light masks for your face, but actually red light for your body is really important for healing. And that healing process, it actually impacts healing your mitochondria. So that's why red light becomes really important. So one of the things they suggest is for all of us to get outside at sunrise and sunset so we can get access to that red light. Obviously, it's very cloudy in England sometimes, so it's very hard to access, but you can now access red light therapy at different clinics. I actually have started working with a longevity clinic called Biogenna. It's based in Regent Street, and I can share more details in the email we'll send you after this. And that's going to be really healing for you. Circadian rhythm alignment. What does that mean? So circadian rhythm is the rhythm and that we have that aligns with day and night. So our body has its own little internal 24-hour clock. Some of us actually lean towards being early birds, and that means our clock is slightly shorter. Some of us have our clock that's slightly longer than 24 hours. That means we're more like night owls. But we need to align with this. So if you're to waking up with sunrise and sunset, it's very hard in the UK because in the summer, sunrise is so early, it's like 4:30, and sunset is so late. But and obviously in the winter it's the opposite way around. But what we want to do is try and align a little bit more to this day, evening, daytime and nighttime. So what I have got the light on now, but normally when it gets to sunset, I actually dim all the lights in my house. So I only have lamps on, or I have the dimmers on. Today I've not got the dimmers because I want to have a nice light when I'm recording. And that's very important to help for your melatonin production for your sleep, because if you're not getting enough sleep, that's going to impact inflammation, it's going to impact your hunger and satiety hormone, it's going to impact your mitochondria. The other thing that supports healthy mitochondria is sleep. And when we talk about sleep, it's stress management. We're all chronically stressed. I think at the moment we're getting more information in probably one day than we ever got in a year, or more, with our kind of smartphones and the internet and the news, and some of the things that we're obviously all kind of witnessing right now are quite upsetting. but we do need to manage our stress. I think midlife's also a time in life where often our sandwich generation, we might have young kids, we might or young or younger kids, and we might have aging parents that we're trying to look after. It might be a time in your life when you're kind of reaching the peak in your career, and that all of that can bring stress with it. Plus, I think modern life is just stressful as it is. We don't get enough opportunity to wind down and to relax and to just have time for ourselves. So stress management is very important. But one of the most important is physical activity. And I did talk about this a little bit earlier on. So when it comes to physical activity, we want to obviously be doing our cardio. But we also want to be doing resistance strength training, and we want to be looking at progressive overload. What does that mean? So naturally, each decade after age of 30, we're losing bone mass and we're losing muscle mass. And what we want to do is start using strength training, resistance training with progressive overload, meaning that we're making it harder each time. So whether you're doing more reps, whether you're lifting more weight, whether you're doing it faster, whether you're doing it slower, all of this can lead up to progressive overload. And when you have more muscle mass, this is really important for your metabolic health and for insulin resistance. Muscle is an amazing buffer for glucose. And the more muscle you have, the more your body can buffer the glucose. So they're not in as many peaks and troughs. So this is where it's very important. It's also really important for healthy mitochondria. It's important for body composition. It's important for your metabolism because the more muscle you have. So this is where physical activity, if that's one thing I can help you to take away from this talk, is please start doing some resistance training. So on the flip side, what damages our mitochondria? So PUFA. PUFA means polyunsaturated fatty acids. Now, it's interesting. It's a question that a patient asked me earlier today, but there's a lot of conversations about the ultra processed diets and things like that. When we've evolved as human beings, we had a ratio of 1 to 1 when it came to omega-3 fatty acids to omega-6 fatty acids. So monounsaturated fats, things like olive oil, nuts and seeds, avocados, they're high in omega-3s. Now, seed oils like sunflower and rapeseed and kind of any processed food which might contain those oils, they're much higher in omega-6. Also, plants are higher in omega-6. Now, that ratio now has changed from 1 to 20, meaning we have 1 part omega-3 to 20 parts omega-6. So what we want to do is actually change that ratio. We know that these monounsaturated fats, these olive oil, the nuts and seeds, avocados, or thing, actually, and then if you have more of those, it'll just change the balance. So that will support you having healthier mitochondria, also decreased inflammation, which is very, very important, as we know, because when we go back to some of the previous slides, we know that inflammation and that pro-inflammatory state. In fact, let me just go back. Oh, here we go. Missed it. So when you have this more pro-inflammatory state, our metabolism is dysregulated. We have that low-grade inflammation, but also that damages our mitochondria. But it also means that we have poor glucose control. So definitely something to remember. Oops, it's got stuck. Excess iron and heavy metals. This is something we need to understand a little bit more about and why that happens. But we do know that if you've got heavy metals like lead, that it can damage your mitochondria, and it's obviously not good for your health. If you have low thyroid hormone, which I was talking about earlier, that can obviously damage your mitochondria. Stress and high cortisol levels, again, they can damage your mitochondria. And if you have an estrogen imbalance, so it's not that estrogen's bad or good, it's just that imbalance. So in modern life, a lot of us females have had estrogen dominance, meaning we've had a lot more estrogen in relation to our progesterone. And so for us, that can also damage mitochondria, and that can lead to things like PCOS, endometriosis, some of the things that we're starting to learn a little bit more about now. There's a little bit more investment into women's health, but all of these things become really important. So what can we do? There's lots of things we can do. So first of all, you want to keep an eye on your metabolic syndrome parameters. I'm going to just go back to just reflect on those, what those are for you visually, so you can have a look. Whoops, sorry. Oh, it keeps getting stuck. Don't know why. Not going back. Oh, here we go. So you're looking at your waistline, your fasting glucose being high, your high cholesterol, your HDL cholesterol being high, low, and your LDL being high, your triglycerides being high, and your blood pressure being high. So all of those things, you want to really keep an eye on those. Oops. Don't know why it keeps getting stuck. So do ask your GP or your primary care physician to check those for you. You want to be testing your glucose and insulin. You want to be checking your lipid profiles and markers of inflammation, like your CRP. So generally in the UK, once you reach age 40, your GP will actually invite you to have blood tests and to test these things. So please do go along for that. Don't just avoid it. Because if you ask for a blood test, you can also ask for your thyroid to be tested, your TSH, your thyroid stimulating hormone. And if there are any issues with that, it's over 4.83 or something, then you can ask for an advanced thyroid panel. However, in the NHS at the moment currently, they do not test all the different parameters of your thyroid. So they don't test the T3 or they only test T4. So, but that's a whole other conversation. You want to support your mitochondrial health with this nutrient-rich diet. What does that actually look like? So you want to be eating a lot of plants, a lot of fiber, those colorful polyphenols. Now, the antioxidants are all the foods that give it color. So if you think about Eat the Rainbow, which if you've ever heard me speak before, I feel like I say a million times, those particular colors. So for example, if you look at the orange and the yellow, so like the pumpkins and the squashes and the mangoes and all of those things, they're high in beta carotene, which is converted by our body into vitamin A. That can protect our mitochondria, but also is a really powerful antioxidant which can help to neutralize that oxidative stress. So we want to be having lots of anti-inflammatory foods, anti-inflammatory diet. So that means eating more omega-3 fatty acids. So in conjunction with the monounsaturated fats that we talked about, which are the olive oil, the nuts and seeds, the avocado. We want to be having oily fish. If we eat oily fish at least twice a week, we want to be having an omega-3 supplement. If we don't, and even if we do, we probably these days, because our fish sadly isn't got rich in as many of the omega-3s, particularly if we're having farmed and not wild. So we may need to supplement anyway. And we want to, so all of these things, colorful fruits and vegetables, which are high in vitamins A, C, B, E, K, all of these are really important for neutralizing these reactive oxygen species. And the other thing we want to do is look at our metabolism. So we want to think about how our glucose and our insulin is regulated or dysregulated. If you eat more protein and fiber, the insulin spike will be less than if you're eating more carbohydrate based foods. That doesn't mean carbohydrates are bad. Your body and your brain need carbohydrates. It's about thinking about how quickly the glucose is released into our system. So if you're having more unprocessed foods, so if you're thinking about maybe whole grains like brown rice or seeded sourdough or whole grain pasta, all of those things will release blood glucose a little bit more slowly than the white versions. So do think about that, and do think about adding more fiber into that with your food. If you pair your meals with protein and fats, that also helps to reduce the glucose spikes because it releases glucose a little bit more slowly. It takes a while for your body to metabolize them. So think about these whole food diets. Then obviously physical activity. And this is really, really important as we just talked about progressive overload and strength training and building more muscle. However, to build more muscle, what do you need to do? You need to eat sufficient protein. What people don't think about is that your body requires even more protein when you're going through midlife, whether you're male or female, but particularly through menopause. To help with them a metabolic to help with your metabolic health and to help maintain your muscle mass. So what is the ratio that I generally use? I use 1.6 grams per kilogram of your body weight. So let's say you weigh 70. So I'm going to have to use my calculator here. This is terrible. Sorry, I cannot do this in my head right now. And you're going to all forgive me for that. That's all good. So if you weigh 70 kilos, then if you do it by 1.6, the answer is you need to have 112 grams of protein. That's relatively hard. You want to be aiming for about 30 grams of protein in each meal. It may mean that if you're vegetarian, it's going to be hard to get. You want to focus on at least 30 to 40 grams at each meal if needed. If you want to add in protein shakes, do add them. I've just been discovering clear protein, which is actually not as heavy on your stomach as having a whey or pea protein or whatever shake. But you do need to think about it. But things like Greek yogurt, if you have 250 grams of whole fat Greek yogurt, that provides 25 grams of protein. Add in some nuts and seeds, that will probably increase it by 5 grams, and then have your berries. So that would be a really good meal to start off your day and your breakfast. Each egg has 6 to 7 grams of protein depending on the size. So you do need to think strategically. You can't just eat 3 eggs. You then need to think about having some smoked salmon. Then you want to think about some vegetables and some fiber. So that is really important. Sleep is our recovery time. Sleep is so important for our mitochondria. It's important for our metabolic health. It's also something that we're all poor at. I think we're all on our screens too late. I know personally I'm a poor sleeper. I'm not very good at converting melatonin, serotonin, our happy hormone, into melatonin, our sleep hormone. That's one of the things that we look at in the genomic testing. And then we can obviously supplement with that. But more importantly, sleep is very important. So how do you protect your sleep? Is your room cool enough? Are you removing all screens from your bedroom? Are you reducing blue light? Are you, is your room quiet enough? Is it dark enough? All of those things to help protect your sleep. Stress management. We've talked about how stresses really impacts our mitochondria, metabolic health. There's so many things we can do for stress, and it's about maybe little things throughout the day. So I don't start the day without, unless I've meditated. It's a guided meditation all the time, not just sitting there. Breath work, obviously exercise, dance, singing, humming, yoga. There's so many different ways, but try and build in and schedule them and structure them into your life, because it's very, very important. And I think we're probably facing more stress than we've ever done before. And a lot of it's socioeconomic too. For people who have got adrenal issues, we can do testing like Dutch testing to kind of see what's actually going on with your kind of stress hormones or your adrenals, particularly if you are in perimenopause, because sometimes your adrenals work really hard to combat the cortisol and adrenaline that's being produced, and so then that can impact your weight and
Reduce the
health.
volume.
So I'm going to put you on pause, whoever's talking. If you could just mute yourself, please. And then reducing alcohol. We want to reduce alcohol. Ideally, you don't want to drink any alcohol. This really impacts our sleep. Of course, it's a very social thing to do, but alcohol can impact our metabolic and mitochondrial health even more at this age than it does at other times. So I just wanted to show you this for metabolic flexibility. This is from my friend Naisha. And it's got like a little happy mitochondria here. And it just talks about metabolic flexibility. We want to think about all the things that impact our mitochondria. So we talked about circadian rhythm, we talked about exercise. Breath work's really important. It really helps with the stress management and our mental health too. We want to have happy cells. Intermittent fasting. Now there's a pros and cons, there's a real mix of that, but intermittent fasting can be anything from the 5-2 diet to fasting overnight for 13 hours. But there is something to be said for like having some time where you don't eat food and trying to eat within a kind of maximum 12-hour window. That's definitely something to think. This blue light mitigation, as I said, I should have got my blue light blocking glasses out. We're all subject to it with screens, which we're using the TV and our laptops at nighttime, our phones. We really want to stop using them at least 90 minutes before we go to sleep. Cryotherapy, hypothermia. So things like sauna are really important for mitochondrial health. Also things like cold plunge, wild swimming, all of these things, which I know can help a lot of anyone going through anything midlife, whether it's menopause or anything else, All of these things can help your metabolism and also your mitochondria. And then the mitochondria, poisons, we want to be careful what we're putting near them. And we've talked about some of this earlier. So I'm also conscious that not all of us live in the same world, that, things that impact our metabolic health are, not just our food choices and our gut microbiome, which we haven't even touched on today. But, we've talked about our age, our sex, our genes. But if we're ethnic minorities, so many of us, and I know there's a really lovely mixed group here, that we do have these genetic and genomic differences in our carbohydrate, lipid, and amino acid metabolism. We are born with slightly different epigenetics because of what we've been through and many generations ago and what our ancestors have been through. We have different dietary patterns which can be messed up when we move to different countries, we emigrate. We have socioeconomic status also affects our metabolic health, and our environment and access to facilities. The politics and legal, of course, stress is part of that too. But if we think about, so in the UK, we have access to free healthcare, but then that healthcare is very, very stretched right now. And then there's obviously psychosocial factors. So I am conscious that we can't control everything. It's not individualistic. We want to think about collective care. We want to improve this for everybody, not just individuals, because that's a function of capitalism. But we do want to make sure all of us have access to all of these things, an environment which is better for our health overall. So chronic stress, a really quick slide on this. So our body, obviously there's actual stress. So let's say if you're being chased by a tiger, that would be like an actual stressor. But there's also perceived stress. So let's say you've got a deadline for work, or you've got financial issues, or your children have exams. These are all perceived stress. They're not actually anything happening to your body, but your body perceives this as stress. This impacts your glucose metabolism. So it can lead to glycemic dysregulation, meaning that you can have much more kind of glucose spikes and troughs, and that it won't be metabolized quite so well. This can lead to inflammation and sleep issues, and all of this can impact your metabolic health, your mitochondria, but also your kind of mental health, your physical health. So we need to make the right nutrition lifestyle choices to reduce stress. And if you look have here, the perceived stress is like impacts our neurotransmitters and how we feel, whether we're feeling lack of control or burnout. If we don't have a great diet and we don't have low fiber, we can lead to an insulin resistant obesity. Having low physical activity can impact that. Again, if you've got these inflammatory signals, a lot of this like diseases, allergies, cardiovascular health, arthritis, all of that's impacted by in these inflammatory, cytokines. And obviously obesity and low physical activity can impact that too. And then sleep issues, particularly even if you've got pain or you've had too much caffeine or anything like that, or there's light and dark disruption because of shift work or jet lag, or the time changing, which it will in a 2 or 3 weeks. All of this can be perceived as stress, so something we want to really, really consider. So just a really quick bit about me. Oh, we're perfectly on time. I do see one-to-one patients kind of using the functional and nutritional medicine and obviously the nutrigenomic testing. I actually qualified in that about 7, 8 years ago. Same with the functional integrative training. And obviously I work a lot in cancer, but I also work with other things, and I'm a researcher. So do take the QR code that does take you through our website and to other kind of resources. What we will be doing is we will be do follow me on Instagram. I'm trying to share a little bit more these days, or Facebook. But what we will do is we will send you a recording of this and maybe a little one-page worksheet as well. I haven't actually made that yet, but I will do that. So let me stop sharing so we can look at questions. Right, if you have any questions, pop them in the chat or just unmute yourself and we can answer those for you. Anyone got any questions? And if you don't, that's fine too. But if you do, like, there's no such thing as a stupid question. I'm really happy to answer it. And okay, someone's in here.
Oh, I've got a question, if that's okay.
Yeah, please.
So I'm Japanese, and often everyone talks about olive oil and how the health benefits of it, but it just doesn't suit East Asian cooking. Do you have
100%.
any recommendations for kind of healthy oils that I could be using instead?
So the thing is, extra virgin olive oil is what we normally talk about when we're talking about these things. So you can get light olive oil when it's for cooking, but then even rapeseed oil has a little bit more omega-3 than sunflower oil or any of those what would be called. So I would look I would look at that too. I totally understand from a taste perspective, it's something to think about. But the second pressing of the olive oil often doesn't have that olive oil taste, so it's often quite a useful way to kind of be somewhere in the middle. So I totally understand, like, with Indian cooking, Southeast Asian cooking, as in, like, from Thai or Cambodia or any of those same sort of issues. You don't want to necessarily have those flavors. Typically Japanese food is so beautiful and clean and fresh tasting. I can totally understand that, but having a little bit. The only good thing, one of the other good things about olive oil is that, and then I'm not talking about extra virgin, I'm talking about the second pressing, is that when you heat it up, it doubles its volume, so you need to use a lot less than other oils. So that's, sorry, I couldn't fully answer your question, but hopefully I gave
Yeah,
you.
that's okay. Thank you so much.
Welcome. Um, is the genetic testing you do very different to the 23andMe markers? Yeah, the 23andMe markers is kind of looking at your ancestry more than your genomics. If you use the raw data, we can convert some of those into understand the single nucleotide polymorphisms, but it means putting it through a program. And so the answer is it is different. Sorry, there was one question above this. Razia, I haven't worked with lupus. That's not one of my autoimmune diseases. I can recommend someone who's excellent. It's not something I work with personally. With the blood pressure, the other end of the scale, does very low blood pressure affect metabolic health too? It can do, but not so much in the same way, because that metabolic, the high blood pressure, the low blood pressure, it's got other impact on your body. It's got impact on your brain. It's to do with it's actually got very different reasoning for it. It's more to do with kind of the salts in your system, how your kidneys are working, things like that. This is quite different. It doesn't necessarily have an impact on your metabolic health in the same way. Although if your blood pressure is fluctuating and going from very high to very low, that could be linked to your metabolic health. You're welcome. Has anyone else got any questions or thoughts or anything you want to ask? It doesn't have to be, necessarily related to it. I won't be able to necessarily answer it. Like the lupus question, I don't really work with lupus. And if not, then I'll let you. Oh, Sonal, right, here we go. What can patients ask for specifically when having blood tests at NHS that would not be covered by standard if they're suspecting? Really, really great question, Sonal. Really good. So I would think about, what is your family history? So when you ask for, let's just say you ask for standard blood test, you go to your GP, they will do your full red and white blood count. They will often check your cholesterol and CRP, like your inflammatory markers. They will often test for TSH, which is your thyroid stimulating hormone. I would ask for all of those. I think it'd be also, the other thing you can ask for is a fasting glucose. That would mean that you have to go to the hospital or the phlebotomy service before you've eaten anything or drunk anything. And that could be one thing that you could ask for if you're worried that there's something going on with your metabolic health. But to be fair, if you ask for a blood test, particularly at this point in life, hopefully your GP will do your full red and white blood cells. They will do some sort of inflammatory markers. They will test your cholesterol. They will hopefully test your TSH. And then from that, those are all the basics. If anything is out of range, they'll obviously test, they can test for vitamin D and some mineral markers like vitamin B12 and stuff too. If anything's out of range, that's when they'll go and do a second blood test. So for example, with my thyroid, my TSH was actually borderline. And as I said, I've got subclinical, so meaning it's not like really bad. Then they did an advanced blood test. So you want to use that first one as almost like a screening mechanism, and then go into having some more deeper blood tests. Unfortunately, NHS is very stretched, and there's a lot of blood tests that they don't really cover these days. So for example, when your thyroid, what you'd ideally like to know is whether you're making T3 and T4 and reverse T3 and T4. Now, the advanced thyroid panel does not include that. And if you go to endocrinology, they might do, but the endocrinology are rejecting you unless you're very bad and your TSH is over 10, and given that the level's 4.8, you have to be really, really ill for them to see you, because it's so overstretched right now. So unfortunately, sometimes if you've got health insurance, doing one of these full medicals where they test everything is not a bad idea, because at least once in a while you'll find out everything about yourself. Wait, ESR. Yes, that is generally done as standard as well. So that should be, well, at least your GP should do that. So it's important to know your kind of erythrocyte, the sediment rate. Like it is good, and that's part of the red blood cell count. So hopefully that answers that. Great. Well, thank you, Karen. If anyone's got any more questions, you've got my details. You will get the recording, probably a couple of days because I'm off to a conference tomorrow to speak about wound healing. And I will try and include a little bit of information, just a few little tips on the metabolic health and the mitochondria for you to get started. And if you'd like to, and we'll share a little bit more about that. I'm wishing you a great evening. Now go and dim your lights. Make sure you wear blue light blocking glasses screen. Keep your room cold and try and get some sleep, everyone. Take care. Bye.